Welcome back, folks. This video covers the second half of the Unit 1 test review, starting with number 20 and going through 42. Let's start with number 20. Here we're simplifying an expression. First, we notice we have a to the 3 halves on the top and on the bottom, so they'll cancel each other out. A to the 0 raised to the 3 halves is still a to the 0, because you would multiply the 0 times the 3 halves, and that would still be 0. So we have b to the negative 4/3 on the bottom. We cannot leave negative exponents in the problem, so we move b to the negative 4/3 up to the numerator. Also, a to the 0 is 1. So we have 1 times b to the 4/3, all in the numerator, which simplifies to b to the 4/3. All right, for number 21, we want to simplify what's inside the parentheses first. Let's go to the denominator. We're noticing we have an x to the negative 2 and an x to the negative 3/2. To combine those, we would have to add the exponents. So that's adding negative 2 and negative 3/2. You can see the work over here. Negative 2 minus 3/2 converts to negative 4/2 minus 3/2. Because you have to change the 2 into a fraction that has a denominator of 2. So negative 4/2 minus 3/2 is negative 7/2. So we have x to the negative 2 times x to the negative 3/2 is x to the negative 7/2. If we do the same thing for the y's, you'll do y to the negative 1 and y to the 4/3 and y to the 0. So in order to combine all of those y's, we would have to add negative 1 plus 4/3 plus 0, and this is the work over here. We'll have to change negative 1 to negative 3/3, add it to 4/3, plus the 0 gives us 1/3. So that produces y to the 1/3. We still have the x to the 1/3 or x to the 1/4 on the top, and all of this is raised to the 3/2. Now we have x to the 1/4 divided by x to the negative 7 halves, and we'd have to subtract those exponents. So subtracting 1/4 minus negative 7/2, showing the work over here, that changes to 1/4 plus 7/2 or 14/4, and that gives you 15/4. So combining the two x's would give us x to the 15/4 in the numerator. We have y to the 1/3 still in the denominator, and now we're going to raise that to the 3 halves power. To raise all of this to the 3 halves power, we simply multiply the exponents. So 15/4 times 3/2 becomes 45/8, and 1/3 times 3/2 gives us 3/6, which reduces to 1/2. So this is our final answer. All right, for number 22, let's combine the x's. We're multiplying x to the 1/2 times x to the negative 1/4. We do that by adding the exponents. If you add 1/2 and negative 1/4 by getting a common denominator, you'll end up with positive 1/4. So that's x to the 1/4. Let's combine the y's together. We have y to the 0, y to the 3 halves, and y to the 4/3. If you add 0 plus 3 halves plus 4/3 by getting a common denominator, you'll end up with 17/6. So that's y to the 17/6. In the denominator, we raise x to the 5/3, giving us x to the 5/3, and then y to the 1/2 raised to the 5/3. We would have to multiply those exponents. So multiplying 1/2 times 5/3 gives us 5/6. Now we have to divide the two x's and the two y's. To divide the two x's, we have to subtract the exponents. So that would be 1/4 minus 5/3. When you get a common denominator and subtract, you get negative 17/12 for x. We also are dividing the y's, which means we're going to subtract those exponents. We would be subtracting 17/6 minus 5/6. That leaves us with 12/6. Now, we take the x to the negative 17/12 and move that to the denominator because we can't leave negative exponents in the answer. 12 over 6 reduces to 2. So our final answer is y to the second power on the top divided by x to the 17/12 on the bottom. All right, for number 23, the first step is to combine u squared times u squared by adding the exponents, and you would get u to the fourth. The next step is to distribute the negative 1 into the exponents here. So you'd multiply negative 1 times 4 and then negative 1 times 1, and you get u to the negative fourth and v to the negative 1. And then the next step would be to divide the u's by subtracting the exponents. So that would be 2, take away negative 4, which would be 2 plus 4, and that gives you 6, or u to the 6th. And then you're going to subtract the exponents on the v's, which is 3/2 minus negative 1, which is 3/2 plus 1, and when you get a common denominator, you'll end up with 5 over 2. So this is our final answer. For number 24, you'll multiply the coefficients 4 times 3 to get 12. For the two m's, you'll add the exponents of 1/2 and 4/3. 1/2 plus 4/3, after you get a common denominator, would be 11 over 6. And then you still have your n to the negative 2/3. Now, we can't leave a negative exponent, so we move the n to the 2/3 on the bottom. And it would be okay to leave your answer like this. For number 25, you multiply the coefficients 2 times 2 to get 4. You bring down the a, and then you add the exponents of the b's. This is b to the first, and this is b to the 1/2. 1 plus 1/2 is 1.5, or 3 over 2 as a improper fraction. So your answer is 4a, b to the 3/2. For number 26, we're multiplying the 3 times the 4 together, so our coefficient is 12. We'll combine the u's, that's u to the negative 3/4 times u to the negative 1/3, by adding those exponents. So negative 3/4 plus a negative 1/3, after combining or getting a common denominator, would be negative 13/12. And then you still have v to the 3/2. Take the negative exponent and move it to the denominator, so your final answer is 12 v to the 3/2 over u to the 13/12. For 27, really the only thing you have to do is take the negative 1. You see the negative 1 there, we want to make that positive, so we just would create a fraction and move all of that to the denominator. So it would end up being 1 over 4a squared b to the 4th, and that's your final answer. All right, so for 28, I multiplied b times b to get b squared, and then just brought everything else over. All right, then the next step would be to subtract the exponents. We have b to the first and b to the second, so that would be 1 take away 2 would give you negative 1, so that would be b to the negative 1 on top. Also, I moved a to the negative 2 to the denominator, and so now I would have a to the second times another a to the second, and then I would add the 2 plus the 2 to get 4 in the denominator, so that would be a to the 4th there. Then the b to the negative 1 has to be moved to the denominator to make it positive, and so you end up with 1 over 4 a to the 4th b. All right, for 29, I just combined all of the like variables inside the parentheses first. So we have a coefficient of 2 in the denominator. We also have x to the 4th and x squared in the denominator. 4 plus 2 makes 6, so that would be x to the 6th. Add the exponents on the y's. That's 4 plus 4. That's going to be y to the 8th in the denominator. All right, numerator stayed the same. The next step is subtracting the exponents of x. So that would be negative 3. Take away 6 would be negative 9. So it would be x to the negative 9 on the top. Also subtract the 2 and the 8. 2 minus 8 is negative 6. So that would be y to the negative 6 in the numerator. Then you can distribute the negative 4 inside by multiplying those exponents. It's negative 9 times negative 4 is 36. And negative 6 times negative 4 is 24. Okay? And also the 2 would be raised to the negative 4 as well. So you end up with 2 to the negative 4 in the denominator. Finally, you move the 2 to the negative 4 up to the numerator to make the exponent positive. So we have 2 to the 4th times x to the 36 and y to the 24th. And then finally, 2 to the 4th is just 16. So this is your final answer. All right, for 30 in the first step, we have x to the negative 1 and x to the negative 2. Adding those exponents, you'd get x to the negative 3. Adding the exponents on y, that's negative 1 and negative 3, that makes y to the negative 4. In the denominator, I just distributed the exponent, so that would be 2 to the second power is 4. And then you multiply the exponents times 2. So negative 1 times 2 is negative 2, and negative 4 times 2 is negative 8. The next step, I reduced the fraction 2/4 to become 1/2. Also, you would subtract the exponents. Negative 3 minus 2, negative 3 minus negative 2 is negative 1. And also, negative 4 minus negative 8 is positive 4. And then the last step is to move the x to the negative 1 into the denominator to make the exponent positive. So this would be your final answer. All right, for 31, the first thing I did was added the exponents of the y's. This is 1 and negative 4. 1 plus negative 4 is negative 3. The next thing I did was canceled out the x's. You have an x on the top and bottom, so they'll cancel each other. Also, this y to the negative 3rd, you can just move that down to the denominator. And so that would be y to the 4th and y to the 3rd on the bottom. And so you'd add the 4 plus 3 to get y to the 7th on the bottom. So this is your final answer. All right, for number 32, we're simplifying the expression. We have the cubed root of 192 x to the 5th. I split up 192 into 64 times 3. And the reason I use 64 is because it is a perfect power of 3, and 3 is the root. And I split up x to the 5th into x to the 3rd times x squared. All right? The cube root of the cube root of 64 is 4. The cube root of x to the 3rd is just x. And then the 3 is left inside, and x squared is also left inside. So this is your final answer. All right, here's number 33. We have 4th root of an expression multiplied by the 4th root of another expression. So because these are both 4th roots, we can multiply everything inside together. 15 times 27 is 405. X to the 6th times x to the 5th is x to the 11th, because you would add those exponents. Y to the 4th times y to the 9th is y to the 13th, because you add those exponents. Now I split up 405 into 81 times 5. And I split up x to the 11th into x to the 8th times x to the 3rd. I split up y to the 13th into y to the 12th times y to the 1st. The reason I did that is for the x to the 11th, I went down to x to the 8th, x to the 3rd, because 8 is divisible by 4. And for y to the 13th, I used 12 and 1 because 12 is also divisible by 4. Now, the 4th root of 81 is 3. That's because 3 to the 4th power is 81. The 4th root of x to the 8th is x squared. The easiest way to get that is just dividing the 8 by 4. The fourth root of y to the 12th is y to the 3rd. You get that by dividing 12 by 4. It gives you 3. So now we have the fourth root of the 5 that's left over, x to the 3rd is left over, and y is left over. So that remains inside the radical. And this is your final answer. All right, here's number 34. We have the fourth root of the square root of the 7th root of x to the 43. What we're going to do is work from the inside out. First, we look at the 7th root of x to the 43. That can be written as x to the 43 over 7. And then you have the square root over that. So that means that's raised to the 1/2 power. Because square root means you're raising it to the 1/2. And then you're raising all of that to the 4th root, which means you raise all of this to the 1/4 power. Then you multiply all three of these exponents together. That's 43 over 7 times 1/2 times 1/4, and that gives you 43 over 56. So you have x to the 43 over 56, and then you convert that back to a radical, which would be the 56th root of x to the 43. Final answer. All right, starting with 35, we are simplifying these fractions. We notice that we have a binomial with a radical in the denominator. You know you can't leave radicals in the denominator, so we'll multiply the top and bottom by the conjugate of the denominator. The conjugate of 1 minus the square root of 5 is 1 plus the square root of 5. So you multiply that on the top and bottom. When you distribute on the top, you get 2 plus 2 radical 5. When you distribute out on the bottom using FOIL, you get 1 plus the square root of 5 minus the square root of 5 minus 5. The two square root of 5s cancel each other, and that leaves you with 1 minus 5, which gives you negative 4 in the denominator. All of this can be reduced, dividing by 2, and you get negative 1 minus 1 square root of 5 over 2. And I also moved the negative from the denominator to the numerator. So this is your final answer. For number 36, you are adding the complex numbers, which means you simply add the like terms. 1 plus 4 makes 5, and negative 6i minus 4i makes negative 10i, and that's your final answer. For number 37, you are subtracting these complex numbers, so you simply subtract the like terms. That's negative 4 minus negative 3, which is negative 4 plus 3, and that's negative 1. I minus I is 0, so those i's cancel out, and so your final answer is just negative 1. For number 38, you have to distribute to multiply these two complex numbers. Some would say you would use FOIL. So you'd multiply negative 6 times 4 is negative 24, and negative 6 times 6i is negative 36i, and I times 4 is 4i, and I times 6i is 6i squared. Now you remember I squared is negative 1, times 6 would make that negative 6. You would combine negative 36i plus the 4i, and that gives you negative 32i. You'll then combine negative 24 and negative 6 to make negative 30. So your final answer is negative 30 minus 32i. For number 39, I would multiply the negative 2i times the 4i, and that would give me negative 8i squared. Now I squared is negative 1, multiplied by negative 8 makes that positive 8. Now let's distribute the 8. 8 times 5 is 40, and 8 times negative 8i is negative 64i. This is your final answer. For number 40, I have to get the I out of the denominator, so I'm going to multiply by I on the top and bottom. On the top, negative 1 times I is negative 1i, or just negative I. And on the bottom, negative 6i times I is negative 6i squared, but I squared is negative 1, so that being multiplied by negative 6 makes it positive 6. So your final answer is negative I over 6. For number 41, I want to get the I out of the denominator, so I'll multiply by I on the top and bottom. On the top, you'll distribute. I times 10 is 10i, and I times negative 5i is negative 5i squared. On the bottom, I times 3i is 3i squared. On the bottom, I squared is negative 1, times the 3 makes that negative 3. Going back to the top, since I squared is negative 1, multiplying that by negative 5 makes it positive 5. Now the negative on the bottom, you don't want to leave negatives in the denominator of a fraction, so let's move the negative up to the top, and let's rearrange the top. So it would be negative 5 minus 10i all over positive 3. And for number 42, you want to get rid of the I in the denominator, so we'll multiply by the conjugate of 4 minus 5i on the top and bottom. And the conjugate of 4 minus 5i is 4 plus 5i. Distributing on the top and using FOIL, you'll end up with 32 plus 40i plus 12i plus 15i squared. In distributing on the bottom using FOIL, you'll get 16 plus 20i minus 20i minus 25i squared. Now going back to the top, I squared is negative 1 times 15 makes that negative 15, and add 40i and 12i to get 52i. Going back to the denominator, the 20i and the minus 20i cancel each other, and then I squared times negative 25 turns that into plus 25. Staying on the denominator, 16 plus 25 is 41. And then 32 minus 15 in the numerator makes 17. So your final answer is 17 plus 52i over 41. All right, that concludes part 2 of the Unit 1 test review.